Okay, let's look at kit questions for forecasting. Okay, let's start. The following four data pairs have been obtained: 1, 5, 2, 6, 4, 9, 5, 11, without carrying out any calculations. Which of the following correlation coefficient best describes the relationship between X and Y? Without calculation, they said. They wouldn't know whether you have done calculation or not. So these kind of questions are like stupid. So they wouldn't know whether you have done calculations or not. So you could just do calculations and find answer. But what they mean is educated guess. If we wanted to do educated guess, you don't have to. You could just do calculations. Okay, so which one would be correct? So if X and then Y, X, Y, so there's a positive relation because one increases, another increases as well. So you would eliminate A and B because they are negative. So when we have 1, then 5, then 2, 6, 4, 9, 5, 11. They seem, if we wanted to choose between 98 and 25, then it seems more like 98 than 25. Because 25 would mean very small change. But we can see with change in X, we have a change in Y. So if I wanted to do educated guess, I would select C. If I wasn't sure, I would just do calculations. Okay, using the equation, what is the predicted reject rate for an operative with 12 months experience? A company's management accountant is analyzing reject rates achieved by 100 factory operatives working in identical conditions. Reject rates Y are found to be related to the months of experience. X by this regression equation, Y equals 20 minus 0.25x. The correlation coefficient R was 9. So we are using this equation and we need to find B and A. Both of these are given. So A is given and B is given. So X is the month of experience. Remember, this is not used to calculate total cost. It can be used to find anything. So in this case, we have 20, which is the rejection rate when a person newly joins. And as experience increases, rejection rate decreases. That's why we have a minus sign. So there's a negative relation. Remember, this correlation coefficient is given, but we don't use that in formula. It will only tell us about relation. It will tell us how strong this estimate is going to be. Otherwise, it is just given for confusion. So if 12 months experience is gotten, so rejection rates would be 17, which means A. Which two of the following increases the reliability of forecast? Remember, the thing about reliability forecast is that it relates to the future, and future is not reliable. But there are some factors which will make the forecast more or less reliable. So they are asking which of these factors will make forecast more reliable. A regression equation Y equals A plus BX is used to forecast the value of Y for a given value of X. Which two of the following increases the reliability of forecast? A correlation coefficient numerically close to 1, working to higher number of decimal places of accuracy, forecasting for value of X outside the range of those used in sample. A large sample is used to calculate a regression equation. Let's first eliminate the obvious. They said forecast for values of X outside the range of those used in sample. What this means is, let's say our data is made from value of 100 into 300. So we have data in the past which has related from 100 to 300 units. So if we want to forecast data for anything between 100 and 300, it would be more reliable than if we wanted to estimate for data more than 300 units, let's say 500 units, or less than 100 units, let's say for 50 units. Because in that range, estimate is going to be more reliable. So we can eliminate this. Next, working to higher numerical decimal place of accuracy. This also seems correct, but when A and D is present, then this is less correct. Let's look at A correlation coefficient numerically close to 1. The more value is closer to 1, the more reliable it is going to be. Like in this example, let's say if the value of this was 0.50, then this estimate would be less reliable than now that it is 0.90. It doesn't matter whether it is minus or whether it is plus. The closer it is to 1, the more reliable. A large sample is used to calculate regression analysis. The more the data, the more reliable the estimate. If x equals 12, y equals 42, x squared equals 46, y squared 542, sum of xy equals 157, number of data equals 4. Where is the correlation coefficient, which is r? So this is given to you in exam, so you just have to put this in formula. So I would expect these type of questions to come in exam. Otherwise, doing the whole thing for 2 marks, I would not believe that they would ask it. Maybe they give you a figure for some of them and then they leave one of them to do some. Otherwise, I wouldn't expect that they will give you a data and then you have to do all of these things. So they will be given to you. You have to put it in formula. So let's see. We have pair of data, which is 4 multiplied by sum of x into y, which is 157, minus sum of x into sum of y, which is 12 multiplied by 42. It becomes 124. Now let's look at the bottom. So my recommendation is do this formula in parts, or doing it in one step in calculator would be very difficult. So now let's look at the bottom part. We have 4 multiplied by sum of x squared, which is 46, minus sum of x squared, which is 12 power 2. And then multiply that by doing the same thing for y. Y squared 542 minus y squared. So now let's put this in calculator. Find square root of it. We have 127. Now take 124 divided by 127. So it is 0.97. If we round it off, 0.98, A is correct. So remember, you either put this in calculator right or wrong. So if you get an answer that is closer to 1, then you know that you have calculated it right. So in this example, A is correct. Okay, which two of the following statements shown follow from above? Using data from 12 European countries, it has been calculated that correlation between the level of car ownership and the number of road deaths is 0.73. So which two are correct? So remember, in questions like these, read all the options and then decide. High level of car ownership causes high level of road deaths. There is a strong relation between level of car ownership and number of road deaths. High and strong. 0.73 is high, but it is not strong. So obviously one of them would be correct. Strong is more than high, so this is high, but it is not strong. Strong would be near 90%. So A is correct here. 53% of variation in the level of road deaths from one country to the next can be explained by corresponding variation of the level of car ownership. Remember, when we take R and we take square of that, it becomes that percentage, which gives us the percentage change. So becomes 53%. So this is correct. Correlation coefficient doesn't give you percentage. When you take square of that, then it gives you percentage. So We can select B and C. Moving forward, which two of the following are true? Regression equation equals y equals 3bx from 6 pair of data x ranging from 1 to 10. The correlation coefficient is 0.80. There is estimated y equals 43 when x equals 20. Which of the following are true? The estimate is not reliable because x is outside the range of data. Okay, our pair of data is 6. It is ranging from 1 to 10. And we are estimating for x, which is outside the range. So this seems like correct. But we will wait. The estimate is not reliable because the correlation is low. This is not low correlation. Low would be 50% or less. This is high correlation, so this is wrong. Estimate is reliable. We'll wait. Estimate is not reliable because the sample is small. Because of the factor that we are estimating the data outside the range, which is 20, that contributes that it is not reliable. And also because the sample is small, we only have 6 pairs of data, because of which I would choose estimate is not reliable because it is small and it is outside the range. Because if I select this, then this would be wrong. Estimate is not reliable because x is outside the range, so it would be contradicting. So A and D would be correct. In calculating the regression equation linking two variables, the standard formula for regression coefficients are given in terms of x and y. Which of the following is true? X must be the variable which will be forecast. It does not matter which variable is which. Y must be the dependent variable. Y must be the variable shown on the vertical axis of the scatter graph. Okay. Remember, it doesn't matter whether you put y on vertical axis or horizontal axis. It depends on how you make the graph. So this is wrong. Usually we put it on vertical axis, but it doesn't have to be. So this is wrong. X must be the variable which is forecast. No, we forecast y for a given variable of x. We find y. So like in this equation. Yeah, in some equation y might be given just as an equation to estimate x, but that is not why we use the equation. It doesn't matter which variable is which, it matters. Y must be the dependent variable, yes. So C is correct here. What is the value of A? A company uses regression analysis to establish the total equation for budgeting purposes. Data for the past month is as follows. We have month, total cost, and quantity produced. The gradient of the line is 17.14. Remember, gradient of the line is that variable bit, which means B. So students who don't understand this, they will calculate B because they are asking A. You can't calculate A without calculating B. So those students that don't understand that this is B, they would calculate B. So this is B, we have to calculate A. So for A, we need sum of Y, which is, so in cost and quantity, obviously this would be Y. So sum of Y is 200 divided by pair of data, which is 4. And then minus B, which is 17.14, multiplied by sum of X, which is 5.75, divided by pair of data, which is 4. Which becomes 25.36. Okay, moving forward. What is the value of A in the equation for the line of best fit to 2 decimal places? Regression analysis is being used to find the line of best fit, so y equals from 11 pair of data, the calculations have produced the following information. We have sum of x, sum of y, x squared, y squared, sum of x into y. What is the value of a? So now b is not given. We have to find b and then a. So b is pair of data, which is 11 pair of data, multiplied by sum of x into y, which is same as the top of this formula. Sum of x into y equals 13,467 minus sum of x into sum of y. Sum of x equals 440, sum of y equals 330. So we have the top bit, which is 2937. So 11 pair of data, sum of x into sum of y. Yeah, it seems right. And divide this by pair of data multiplied by sum of x squared, which is 17,986 minus sum of x squared, which is 440 power 2. So let me double check that I've done this correctly. And sum of x squared let me double check with my calculator. 4 multiplied by 17,986 minus 440 power 2. Yeah, it seems correct. So 23937 divided by 121,656. Let me see, I've taken the figures correctly. We have x squared. Yeah, it's correct. And then x squared here. Okay. So we have minus 0.0241. I'm still not confident that I've calculated this right. So let's double check. We have pair of data, x squared, and then minusing this. Okay, I've taken 4 pairs of data, but here we have 11 pairs of data. So we have 0.6917 for the b, which is the variable bit. Now put this in calculator, put this in formula of a. So we have sum of y, which is 10,366 divided by 11 pair of data minus 0.6917 multiplied by sum of x 440 divided by pair of data 11. Sum of y 330. I've taken sum of y squared. So we have 2.33. So the equation would be 2.332 plus 0.6917 multiplied by x. Which of the following is a feasible value for correlation coefficient? Feasible area means area where the answer could be minus 0.2, minus 2, minus 1.2, 0, plus 1.20. 0 is correct. So the answer would be anywhere between plus 1 to minus 1. It could be 0 as well. 0 would mean there is no correlation. What is forecast for number of items to be sold in month 19? Over an 18-month period, sales have been found to have underlying trend of 7.112 plus 3.949x, where y is the number of items sold and x represents the month. Monthly deviation from 10 have calculated, and month 19 is expected to be 1.12 times the trend value. So this is time series, and we are using multiplicative model. We are using multiplicative model because the variation is given in times. If it is additive model, it will be given as plus minus. So this is the earliest data that we have. With this, we are going to add the trend, which means we have increase of 3.949 every month, and we are expecting for 19 months. So this will give us that average, the trend. And with this, we will multiply by the seasonal variation. So we would estimate the answer to be B92. Based on last 15 periods, the underlying trend y equals 345 minus. So with month increase, sales are decreasing, so decreased trend. If the 16th period has a seasonal factor of minus 2, so this is the multiplicative model. Assume additive forecast model. What is the forecast for that period? Okay, we have 345.12 minus 1.35 multiplied by 16th period. 323.52 minus 23.62. We have 299. If we round it off, it becomes 300, which means A. This also seems like times series, so do that. Monthly sales have been found to follow a linear trend of 9, where y is the number of items sold, x is the number of months. Monthly deviation from 10 have been calculated. An additive model, and month 24 seasonal estimated to be plus 0.24. So it's also straightforward, so do it. Which of the following are necessary if forecasts obtained from time series analysis are to be reliable? There must be no unforeseen events. The model used must fit the past data. Trend must be increasing. There must be no seasonal variation. So which two of the following are correct? First one, there must be no unforeseen events. Yeah, this is correct, because this is one of the reason forecasting is not reliable, because there might be things that we haven't thought of. The model used must fit the past data. Maybe I will come back to this. The trend must be increasing. It's not necessarily true. Even if it is decreasing, we can estimate it. Like in this example, it was decreasing. So it doesn't have to be necessarily decreasing. There must be no seasonal variation. Even if there is seasonal variation, we can still predict. The model used must fit the past data. So this is the only one that is left to be correct. So what we are basically doing in seasonal variation, we are taking the past data and using that to predict the future. Okay, going forward. What are the values of x and y in the original time series? A series of 3-point moving average produced from this data has given the first two values of 38 and 39. What are the values of x and y in the original time series? I actually don't understand this question, so I will skip this. What is the forecast for the actual value for the fourth quarter of 2016 to the nearest whole number? Using additive model, y is given y equals 6 plus 7t, where t is the quarter, t1 is the first quarter of 2015. If seasonal component in fourth quarter is minus 30, what is the forecast for actual value for fourth quarter of 2016? So we have first quarter of 2015, and then we are estimating first quarter of 2015 is given, and we are estimating fourth quarter of 2016. So that will become 8 quarters. Remember, in our calculations, we calculated the jump. But in this question, they said assume the first quarter of 2015 becomes T1. It doesn't become T0. Because maybe we already have data collected maybe from 2014. The ending quarter of the fourth quarter of 2014. Okay, so simple calculations. 65 plus 7, we have 8 quarters. So we would expect 121 to be the average because we have seasonal variation. So we would estimate the answer to be 91. Okay, this also seems seasonal variation time series, so I'll leave it. Which of the following are necessary if forecasts obtained from a time series are to be reliable? Trend must not be increasing or decreasing. Trend must continue as in the past. Extrapolation must not be used. Said pattern of seasonal variation must continue as in the past. Extrapolation means when we extend the line that we had in time series, when we extend that, this is called extrapolation. So they said which of the following are necessary. Extrapolation would make the estimate not 100% reliable, but this is the idea of time series. We are estimating the future. We have to do estimate, even though if it involves future. So the correct answer, trend must not be increasing or decreasing. Even if it is decreasing, even if it is increasing, we can estimate it. It is not a problem. Trend must continue as in the past. That is correct. So it should be the same as the past. This is not correct. The same pattern of seasonal variation must continue as in the past. Yeah, the seasonal variation and the trend should be correct because these are the two things that we use in our time series. Under which of the following circumstances would multiplicative model be preferred to additive model in time series? When a model easily understood by non-accountant is required. So we want to use multiplicative rather than additive. So in which situation would we use multiplicative? When trend is increasing or decreasing, when trend is steady, when accurate forecasts are required. When trend is steady, then additive model can be used because overall seasonal variation would be the same. But when trend is increasing and decreasing, as a percentage it will be the same, but the whole value of the seasonal variation would be different. So then it would be good to use a multiplicative model. We have too many questions. Okay, but let's see. Okay, company's annual profit as a trend line given by y equals t minus 10, where y equals 10 in thousands and t is the years. T0 equals 2010. What are the forecast profits for year 2019 using the additive model if the cyclical component for the year is minus 30? Okay, so we have 20t which is 2019, so we will have 9 years because 2010 is 0, and from this minus 10, $170 and minus the cyclical variation, so we would estimate 140,000 to be profit. So equations are given, you just have to put figures. What is the seasonally adjusted unemployment? So I will leave that to you. What is statement is true? The following statement relate to Pache and last pay indices. Constructing a Pache index is generally more costly than a last pay. Yeah, because you need latest data in Pache. In last pay, you use the old data as base. If you don't understand this, go back to indices in the previous topic that I explained. With a last pay index, comparison can only be drawn directly between the current year and the base year. We do that the same with Pache. With both of them, we do comparison between current and base year. It is not just Pache, not just last pay. The only thing is that when we are using last pay index, we keep the quantity same from the base year, the original year, and when we are using quantity, we take the price the same. So they're actually talking about this as the fixed base index. This is true for fixed base index. So statement 1 is true, second is false. What is the Fisher index? The following information is available for price of material at PICO. Last pay index is 150, Pache is 138. So Fisher is you multiply both and take square root. It becomes 144. Remember, you have to take square root of this. How much does a bag of cement cost in 2016? To 2 decimal places. A large bag of cement cost 0.80 cents in 2013. The price indices are as follows. We have 91, 95, 103, 106. So in 2019, it cost 80 cents and index was 91 there, and now it is 106. So that means it cost 93.19. So we have multiplied by the index of 2016 divided by the index of 2019. What is the best estimate for current cost of material X per kg? 4 years ago, material X cost 5 per kg and price index most appropriate to the cost of material X stood at 150. Now it is 430. So 5 multiplied by 430 divided by 150. 14.33. What is the best estimate of the current cost of material per kg? I will leave that to you. Which of the following are common applications of spreadsheet by management accountants? I think we have already done this in information chapter, I believe. Using the halo method, what is the variable cost per unit? Halo method we have already done. What is the forecast sales volume for the fourth quarter of 2015? The following question is taken from June 2013. An additive time series is the following trends, seasonal variations. We have trend 4000 plus 6x, where y equals sales in units. X is number of quarters, where the first quarter of 2015 being 1, second quarter of 2015 being 2, and etc. So seasonal variation is given. So we are finding the fourth quarter of 2015, and we have data 1 2014, so 8 quarters. So we have 4000 plus 6 multiplied by 8 quarters, and then from this minus seasonal variation. And it is additive model because of the plus and minus sign. Plus 4, I've written 40,000. 4048 plus 5 equals 4053, which means D. What is the fourth quarter centered moving average of sales unit for quarter 4? Center moving average, 4 quarters center moving average of sales unit for quarter 4 of 2014. Center moving average here. So if they've already found average, which is here, this one and this one. So we have to just find average of these two. It would be center moving. 9,000 this is moving total, okay? This is not average. So 9,000 divided by 4 is the average. 11,000 divided by 4 is the average. So now 2250 plus 2750 divided by 2. Center moving would be 2500A. What is the variable overhead cost per unit expressed in 2013 prices? The following question is taken from January to June 2017 exam period. The following information relates to company's semi-variable production overheads. We have output 1,000, 1,200 overheads, 12,400. So I will leave this to you. Using halo method or least square method, you will be able to find the answer. Because it is two things, so you can use halo method. So this is it for forecasting.